In this video, I wanted to go over graphing some basic logarithmic functions. So it's good to be aware of a couple of facts about a parent graph for an equation of the form y equals log base b of x. So a couple of things. If you input b as your x value, then you have log base b of b. So that's basically asking what power of b is b. So that's going to be the first power. B to the first is b. So you always, these graphs of equations of the form y equals log base b of x will include the point b1. They'll also include the point 1, 0. And one way to think about that is if you substitute 1 for x, then you're asking yourself, so log base b of 1 is asking the question, what power of b is equal to 1? And any non-zero base raised to the 0 power is going to give you 1. So that's why when x is your input, 0 is your output. Or when 1 is your input, 0 is your output. I'm sorry. Great. So for log base 4 of x, that's going to include the point 4, 1. So 1, 2, 3, 4, 1 right here. And 1, 0 right here. That's your x-intercept. Now you might have to plot a few other points when you're graphing this in your online homework system. So I'm going to get rid of that just to give myself some room. Oh, I have a hard time getting rid of the... Sorry guys, all the color choices are right underneath the toolbar for the recording software I'm using, so that's why I'm having trouble. So let's see. Make a little t-chart here, and we'll think about so what x values might be easy to plug in. 16 would be 1, because then y would be log base 4 of 16, so you're asking yourself what power of 4 is 16, so the answer there is 2. So when x is 16, y is 2. Now the downside of that is that's like way down here on the grid somewhere, so it's not really easy to plot. But when you're working on this in, like I said, an online homework system, you could input the point 16, 2. So the powers of 4 are going to be the ones that are easy to input for x. I mean, we also have, if x is 1, what power of 4 is 1? That's the 0 power. If x is 4, what power of 4 is 4? That's the first power. Maybe let's do one more, 1/4. So then the y value is log base 4 of 1/4. And you're asking yourself, what power of 4 is 1/4? And that's the -1 power. 4 raised to the -1 power would be 1/4. So when x is 1/4, y is -1. So that's going to give me a point maybe down here. Another thing about the parent graphs. So they always include these 2 points. They also always include not a horizontal asymptote, like I was going to write, but a vertical asymptote at x equals 0. Another way to remember all this information about the graphs of logarithmic functions is to take what you know about exponential functions and just reverse x and y. So the exponential functions always start with this horizontal asymptote at y equals 0. So if logarithmic functions are the inverses, then we just change y to x, and you have a vertical asymptote at x equals 0. So a vertical asymptote right here. And the graph of y equals log base 4 of x looks something like this. It looks sort of like a exponential graph knocked on its side. In case you're asked in your homework, I'm going to quickly go over domain and range for these graphs. So domain, that's all the x values included on this graph. So this graph includes x values from, it gets really, really close to 0, but that's the vertical asymptote, so it's not going to cross that. So it gets close to 0 as the lowest x value, and then goes to infinity for highest y value. So I can put here 0 to infinity. And for the range of these logarithmic functions will be all real numbers, basically every time. So it covers every y value. It's not going to increase very quickly over here to the right, but it is always increasing. So it's going to get to every y value that you need it to get to, those positive y values. All right, so now next I'm going to graph log base 1/3 of x. So we can look at what happens when your base is a fraction that's between 0 and 1. So a couple of approaches. Again, we could start with just what we know about log functions in general. I'm having trouble switching to the writing tool again. Okay, which is that it'll include the point 1, 0, and then b comma 1, which in this case will be 1/3 1, and it's got a vertical asymptote at x equals 0. So it's got a vertical asymptote here at x equals 0. It includes the point 1, 0. It includes the point 1/3 1, which would be up here. And we let's suppose we want to plot a few more points. Just I'll say this as well. It's okay with me when you guys are hand drawing, when you're sketching a graph by hand for, say, an exam question. If you plot those 2 points, you show your asymptote with a dotted line, and then you have the right basic shape for your log curve, that's good enough for me. But it's a good exercise in the homework, maybe not so much for exams, but in the homework to plot a few more specific coordinates. So if we're thinking about what's easy to plug into log, and I say easy, I mean that's relatively speaking, but what we can plug into log base 1/3 of x and figure out a y value. So the ones that we did already, if x is 1, then we're looking for log base 1/3 of 1. What power of 1/3 is 1? And that's the 0 power. So that's where we got that 0.10. If x is 1/3, then we're looking at what power of 1/3 is 1/3. And the answer is the first power. So that's where we got this 0.13 1. Another x value that's maybe a little easier to think about is 3. So what power of 1/3 is 3? Well, those are reciprocals. You need to flip it. So that's the -1 power when it's a reciprocal. So another point, if you were inputting these coordinates one by one into, let's say, an online homework system, when x is 3, y is -1. So when x is 3, y is -1. So I need to fix my curve a little bit if it's going to go through that point. I'll draw a new curve once we maybe plot one more point. That might be all the ones that I can graph on the grid that I've drawn here. If we needed one more, then I might think about using 9. So we think about what power of 1/3 is 9. Well, to get to 9, 2 things have to happen. You have to flip it, so that'll be a negative exponent, and then we need to square it. So 9 comma -2 would be another point, but that's going to be way out here. So I'm just going to stick with those 3 points and sketch that for my curve. One thing to notice, well, and I'll also put the domain and range on here. So domain, again, is 0 to infinity. It covers x values from 0 to infinity. And range is all real numbers again. So notice how that's the same as the previous graph. And so if we look at similarities and differences, both have the same domain and range. Both have sort of the same shape, but for when your base is a fraction between 0 and 1, you're going to get this decreasing shape. When the base is bigger than 1, you get this increasing shape. So it sort of looks like it's reflected over the x-axis, which in a way it is, but yeah, we don't have to really talk about that. So just this shape when the base is bigger than 1, this shape when the base is between 0 and 1. And always includes the points B1, 1, 0, vertical asymptote at x equals 0. Just those 3 bits of information are enough to give you a decent sketch of the graph of these functions.